A deadlock in MySQL occurs when two or more transactions are waiting on each other to release locks, creating a circular dependency where none of the transactions can proceed. In other words, two transactions each hold a lock on resources the other needs, causing a standstill. Deadlocks prevent the system from resolving these transactions, leading to a situation where no progress can be made without external intervention. How deadlocks happen. 1. Transaction 1 locks resource A and then attempts to lock resource B, which is already locked by transaction 2. 2. Transaction 2 locks resource B and then tries to lock resource A, which is already locked by transaction 1. At this point, neither transaction can proceed and the system enters a deadlock. Example of a deadlock in MySQL. Transaction 1 acquires a lock on row 1 of the orders table and tries to update row 2 of the customers table. Transaction 2 locks row 2 of the customers table and tries to update row 1 of the orders table. Both transactions are waiting for each other to release their locks, which creates a deadlock. How MySQL handles deadlocks. MySQL automatically detects deadlocks and resolves them by rolling back one of the transactions. This allows the other transaction to proceed. MySQL typically chooses the transaction that has executed less work, i.e., fewer changes, to be the one rolled back, minimizing the impact on the system. Detecting deadlocks in MySQL. 1 error log. When a deadlock occurs, MySQL writes details about the deadlock to the error log. You can check the error log to get information about which transactions were involved in the deadlock and which one was rolled back. 2. Show engine inod status. You can run this command to view the latest deadlock information, including the transactions involved and the resources they were trying to lock. SQL show engine inodb status. This command provides detailed information about the locks that caused the deadlock. 3. Information schema tables. Inodb locks. This table shows the current locks held by transactions. Inodb lock waits. This table shows which transactions are waiting for locks held by other transactions. How to prevent deadlocks. 1. Access resources in a consistent order. Ensure that all transactions acquire locks on resources in the same order. This prevents circular wait conditions that lead to deadlocks. 2. Keep transactions short. The shorter the transaction, the less likely it is to hold locks long enough to cause a deadlock. Make sure transactions only hold locks for as long as absolutely necessary. 3. Use indexes. Proper indexing helps reduce the scope of locks, especially for select and update queries. This minimizes the chance that multiple transactions will compete for the same rows. 4. Reduce lock granularity. Try to lock the smallest possible set of rows, row-level locking, rather than larger sets, table-level locking, to minimize conflicts between transactions. 5. Deadlock retry logic. When a transaction is rolled back due to a deadlock, you can implement